Hello. In this video, we're going to be looking at Learning Objective 1 for Chapter 1, so our very first one. And we're going to be looking at classifying matter, looking at compounds, molecules, elements in general, and then comparing them to our mixtures. So when we classify matter, we can do it in a couple of different ways. So first, let's just kind of look at what chemistry is and how it relates to matter. So chemistry itself is going to be the study of matter and the transformations that matter undergoes. So, within chemistry, we study matter, which is going to be the physical material of our universe. So things that have stuff. So it's going to be something that has mass and occupies volume. Okay, and we are going to look at matter in terms of physical state and composition. And we'll also look at the properties of it and the different ways we can describe the properties. So we've got three states of matter. We have our solids, our liquids, and our gases. And then we're looking at composition. We're looking at what matter is made of. And here we're going to be looking at pure substances versus mixtures. Okay, so let's start out with our physical states. Physical states of matter: solid, liquid, and gas. Our solid is generally our most condensed state. Meaning that our particles of our state are the closest together. And this almost always holds true except for stuff like water. Now, they can get so close together because we don't have a lot of movement with these. All of these are pretty stationary. All they really do is vibrate in place. So there's very little movement. Of the particles. In a gas. And that's because they're very low energy. So they don't have a lot of energy, so they're not going to move very much. Because they don't move very much, they're going to retain their shape and volume. So they have a set shape and volume. And also, because we are in our most condensed state, we're not going to be able to compress or expand. moving on from there, we go on to our liquids. So our liquids are going to have more freedom of movement. The particles are going to be generally a little bit further apart than a solid, not super much farther. They're pretty close together still, but they have a little bit more movement, so there's usually a little bit more bouncing and shifting. So more movement. We would say that they are free-flowing. So there's more movement because there's more energy. Okay. These are going to be usually a little bit less dense than solids. Again, when we think about water, that's a more dense state, but that's very irregular. Because they have this freedom of movement, they're going to have an indefinite shape. But they are going to still have a definite volume. And they have a definite volume because this is, again, a state that is not compressible or expandable. Okay, last state we want to look at is our gas. So this has so much movement. We've got a lot of energy here. Our particles are bouncing off each other, so they're very, very far away from each other. So this has the most movement. So definitely free-flowing. Most energy. And is without a doubt the least dense. There is so much empty space when we're talking about a gas. The particles are not really anywhere close to each other. So infinitely less dense than a liquid or a solid. Now, because there is so much empty space, we do have a thing, or a state that can be compressed, and because of changing energy changes how much our particles are moving, we can also expand very easily. So this is a compressible and expandable state. So here we're going to have an indefinite volume, indefinite shape. As kind of a note, just kind of thinking about this, we're not going to talk about this too much until we get later into 1211, but our solids, because our substances are so close together, they're going to have the greatest interaction between their particles, while a gas, since they're so far apart, they're going to have the least amount of interaction. And generally substances that interact more are going to lend themselves more to being a solid at room temperature, and then things that don't interact with each other as much are going to be more a gas at room temperature. And that all has to do with how much attraction the particles within a substance have for each other. And like I said, we'll talk about that more. I just want you guys to kind of think about that. Okay, so to get between phases of matter, we have to change stuff about it. So we're not just going to be able to easily go between states. We have to do stuff to it. So if we're in a solid state, this is a state with the least amount of energy. So as we increase the energy by increasing the temperature, we can go from that solid state into the liquid state. And then we can further increase the energy to go from a liquid to a gas. Going the opposite way, if we want to go from a gas to a liquid, liquid to a solid, we need to remove energy or remove heat. So heating up allows us to go from solid, liquid, gas, cooling down, gas, liquid, solid. So When we're going from a solid to a liquid, we call that process melting. Going from a liquid to a gas, evaporation. Going back the other way, gas to a liquid is called condensation. Liquid to a solid is called freezing. And then we can also go from a solid to a gas, and that is called sublimation. And then from a gas to a solid is called deposition. So as we increase our energy within each of these states, we're going to increase our molecular motion. Within a solid, all we have is vibration. So there's just very little movement. As we increase the energy, we increase collisions and movement and everything's going around. So our particles within a liquid are free-flowing. And they have a large amount of energy. And then as we get to that gaseous state, now we're really moving. The things are moving super quick. So, super quick movement. And they are going to have just lots and lots of energy. Let's now move on to looking at composition. So we're looking at elements, compounds, and mixtures. So if we have matter, we are talking about the 118 elements on the periodic table. So no matter what, our composition is those 118 elements, always. But the way we combine those 118 elements into our substances will determine whether we have a pure substance or we have a mixture. So with a pure substance, we're looking at a constant composition. So all the way through, everything's constant. We would call this homogeneous. Okay. And then our pure substances themselves can be either elements or compounds, where an element is what we see on the periodic table. And here we can't break these down into simpler substances via chemical means. Okay. Now, our elements, those are going to be our atoms. And if we're talking about an element, we're talking about all of the atoms. Well, when we're talking about atoms, we're just talking about individual things. So an element is all the atoms of a specific type. And then an atom is an individual. So we can talk about 1 atom, 10 atoms, 100 atoms. They're all going to be composed of the same type of element, but elements are basically just a broader, these are all of our atoms. Atoms are like, these are these individual things. And our elements can be either monoatomic in nature, or they can be diatomic or polyatomic. So our monoatomic, 1 atom. Diatomic, 2 atoms bonded together in a molecule. And then polyatomic, 3 or more. bonded together, where both of these are also called a molecule. Okay. Compounds are when we take two or more atoms of different types and chemically bond them together. Okay. And then, in contrast to our pure substances, we have mixtures. And here we're talking about a inconstant composition. And we form our mixtures by combining two or more pure substances. As a note, these will be combined in a non-chemical way, so they will retain their individual structures. They're not going to combine and make a new thing. Okay, so our pure substances, as I said, they can be elements or they can be compounds. And within there, we can look at our elements as either atoms or molecules, so either monoatomic or polyatomic, including, of course, the diatomics. The diatomics are the most common. And then within our compounds, they can either be molecules or ionic in nature. So our molecules, these are covalent compounds. And then our ions, these are ionic compounds. Okay. So, just a kind of more overview, like with our elements, this is one atom type. And with our compounds, two or more atom types. But both of them are going to have a constant composition. So if we have water, for instance, it's always going to be 2 hydrogens to 1 oxygen. Sodium chloride is always going to be 1 sodium to 1 chlorine. Oxygen gas is 2 O2 molecule or 2 O2 atoms bonded together. Something like neon, and the rest of our noble gases will be individual neons or individual argons or whatever, kind of floating around. So just depends on, how they are bonded, what they're bonded to, or if they're individuals kind of floating by themselves. Okay, so a little more about the elements on our periodic table. So there's 118 of them. And we talk about the idea of an elemental form. So everything on the periodic table has an elemental form. The elemental form is going to be the natural form it takes when it's not combined with another element. Almost every single element on the periodic table is going to be monatomic in nature. So they're going to hang out by themselves, and they'll interact with others of the same type, but they won't form a molecule. So most elemental forms are monoatomic, such as carbon and stuff like charcoal. or diamond. We consider this to be a monoatomic. Because it doesn't form a molecule. If we have diatomics, we're going to have two bonded together in a molecule. So here we're going to talk about things like hydrogen gas, nitrogen gas, oxygen gas, fluorine gas, chlorine gas, bromine, liquid, and iodine solid. So I want you to memorize these. So H2, N2, O2, F2, Cl2, Br2, and I2. Where these right here are all gases. This is a liquid. And then this is a solid. And if you look at the periodic table, you can actually see what state of matter you would expect your elemental form to be in. Generally black on your periodic table means it's going to be a solid, blue a liquid, and then red is a gas. And the last type is our polyatomics. Again, we can consider diatomics, polyatomics, but those diatomics that I've just written are the ones you need to know. Polyatomics are stuff like S8 and P4. So carbon, when it makes stuff like charcoal and diamond, it's going to be an extended structure where there's carbons beyond count. So it's not a molecule, it's an extended structure. But stuff like S8 and S4, we have those bonded to each other in a ring type structure, and they're individual and they will always be in that form. It'll always be S8, it'll always be P4. So we call those our polyatomics. Okay. Let's real quick look at our elemental names and symbols. So what we're seeing on the periodic table are our elemental symbols, and each symbol represents a different element. So each element will have its own unique name and elemental symbol. So we will look at those. The elements themselves on our periodic table are roughly arranged by weight, but they're actually arranged by number of protons. So our number of protons are our atomic number. And that's going to be that number from 1 to 118. Our elemental symbol is what we're looking at on our periodic table. That's going to be a 1 to 2 letter long symbol. Where the first letter is capitalized, and if there is a second letter, it would be lowercase. Our compounds themselves are going to be different from the elemental forms. So the compound properties are drastically different generally than their elemental properties. And we can see that when we look at this table right here, comparing water to hydrogen gas and oxygen gas. Hydrogen gas and oxygen gas are what make up water. They combine to make water, but both hydrogen and oxygen are gas at room temperature with very, very low boiling points. Well, water is a liquid, and they have significantly different densities, and just some of them are flammable, some are not. So very different properties. As a note, our compounds themselves will always have the same elemental composition. We call that the law of constant composition, or law of definite proportions. And this was developed by French chemist Joseph Proust. Kind of keep his name in mind when thinking about compounds and their constant composition. Next, we're going to look at mixtures, so 2 or more pure substances. And these are going to be together in some ratio. That ratio is not set though, which is why it's not a fixed composition. You can have a mixture that's 50% water, 50% salt, or 10% water. Well, 10% salt, 90% water. So when you make a mixture, the compounds of the mixture are not altered. So if you add 2 things together and you alter, you change those, you have a chemical reaction that occurs, you have not made a mixture, you've done a chemical reaction. And then any mixture, if you have a mixture, can be broken down by physical means. Such as filtration or chromatography. We have 2 types of mixtures. We have homogeneous and heterogeneous mixtures. So our homogeneous mixtures are constant composition, or not constant composition, one look to it, you can't see the different components of the mixture. While you're heterogeneous, you can see the different components. Okay. And then our heterogeneous looks just like that, heterogeneous. You're going to be able to see the different components. A special type of homogeneous mixture is a solution. That's the one we study the most within here, within chemistry. And here we have one or more components completely dissolved, so dispersed uniformly within the other component. So the thing that is in greater quantities, we call the solvent. And then the other things in lesser quantities are the solute or solutes. Okay, and our components, these solutes, are going to be very small so that they dissolve completely. Here's just kind of a flow chart going through determining what type of matter there is, or what matter is, either a heterogeneous mixture, homogeneous substance, either a mixture or a pure substance. So you can follow through when you first start to try and figure out what type of composition you have within matter. Okay, so we are just about done with this. We're just going to try out the following problem. We want to classify each of the following as an element, compound, or mixture. So when we're looking, we have something like diamond. Diamond is composed of carbon and nothing but carbon, so this is going to be an element. If we're looking at air, the air around us, it has nitrogen, it's got oxygen, it's got trace horrible things in there, but nitrogen, all sorts of things. But here we have a bunch of different things, so this is going to be a mixture. Water, H2O, 2 hydrogens to 1 oxygen. It is a pure substance, but it is still considered a compound because there's oxygen and hydrogen. Ink, if you ever looked at ink, or done chromatography on ink, that's a very common thing for people to do, where the thing goes up the piece of paper and you see the different components. So this is going to be a mixture. Gold, on the periodic table, it's Au, so this is going to be an element. Sugar, table sugar, what we're used to consuming, it has carbon in there, it has oxygen, it has hydrogen, so this is going to be a compound. Last thing is bronze. Bronze was big in the Bronze Age, and it is a bunch of different metals mixed together, so this would be a mixture. Okay, that's everything for this particular video. I will see you guys later in the next one.